Hello viewers, you can see a question which involves inverse function and composite. So all we've got to do is to read the question, then do nothing short of justice to it. Given that f of x is equal to 3x minus 5 all over 2 and g of x is what? X plus 2. We have to find a f inverse of x, b f inverse of 5, and c f of g of x. Say let y be equal to what? F of x. Why is this so? We are looking for the inverse of f of x. Okay, so if that should be the case, we need to denote our f of x using what? Y. At the end of the day, we bring back the original value because we always have our x as the input, which is the domain. Then y becomes the range, which we see as our what? Output. Then in that case, take note, I'm solving for f inverse of x. In that case, if y is equal to f of x and our f of x is what? 3x minus 5 all over 2. Excuse me. In that case, we can say that if y is f of x and this is what f of x is, so I will need to equate y to this value, because from my illustration or from the argument we can see how we established this value. Then this becomes y will be equal to 3x minus 5 all over 2. The essence of this is to make x the subject of the equation. So if that is the case, we cross multiply. 2 times y will give us what? 2y, which is equal to 3x minus 5. And then what is the next approach? I'll add 5 to both sides. This becomes 2y plus 5, which is equal to 3x. By cross multiplication, we still have 3x is equal to 2y plus 5. Then what is expected? I'll divide both sides by 3. When this is divided by 3, we'll be having x to be equal to 2y plus 5 all over this 3. But we need to take note that we are looking for what? F inverse of x. If that happens to be the case, we say f inverse of x will be equal to 2. We remember that x is always the input. So in this case, we plug in x here. We no more have y, then plus what? 5 all over 3. So this becomes the answer to question A. That is the solution.